In this video, we're going to use fprintf to create a times table, and for an added challenge, let the user tell us which times table they want us to create. So here's the exercise. If you'd like to pause the video, try this, and then restart, we'll work through it together. All right, welcome back. Maybe you got through part of part A. Let's do this together. So our task is to create a times table for the number 5 using fprintf. So I'm going to open up a new window here and create a task. Use fprintf to create a times table, etc., etc. All right, so here's how we could do it. Start with, let's create a equals 5. And one reason I'm doing this instead of hard coding in the 5 is because I saw that second part of the prompt, which was to generalize and allow the user to tell me the value of a, or the times table that they want. But let's start with 5. So let's say this is the times table we will print. And then let's do from 1 to 10. You could go from 1 to 12 if you want. These are the multiples. These are the multiply factors. We're going to multiply each of them times 5 and then print it all in one big table. So let's get an array or a vector showing all the results of that. That's a times x, a star x, and this will be the results of multiplying. And now I need to arrange it all in a table. And since we want to use fprintf, we're not just going to arrange them in a table and show the output. We want to actually build a sentence. So I want to think about how fprintf is going to use these. It's going to go down each column. So I'm going to put my data across in rows. So I'll call it my results, and this will be a. Do I need a? Let's skip a. X semicolon y. That way all my x's will be across and then all the y's, and it will pull one at a time. So I'll call it my results, and now we use fprintf to report the results one sentence at a time. So fprintf, and then I need the string. So let's say 5 times blank is blank. And I'm using D for decimal, which shows an integer. You could also call it I if you want, or maybe you want to use %f with rounding to 0. That'll work too. So like if I did .0f, that's going to round them all to have no digits after the decimal place. That's another way to do the same kind of thing. But I works just as well. So any of those options, because they're all going to be integers. So 5 times the first number is the second number. And then I will add a new line like that, close the string, and tell MATLAB where to get the numbers from. Mine are in my results. There we go. And now let's think and see if this is going to work as I want. If my results has x's across the top and y's across the bottom, it's going to take the first x, then the first y, the second x, then the second y, which I think is what I want. So let's give it a go. Let's see if run section, and here's what I get. 5 times 1 is 5, 5 times 2 is 10, looking good. All the way up to 5 times 10 is 50. Now, one thing you may have noticed is that I did actually hard code the a value here. So if I want my user to tell me which one, I need to change the sentence, because I don't want to put 5 times 3 is 9 if I'm trying to do a 3 times table. So this is a perfectly good solution to part A. Let's just look again at part B and see. If you'd like to pause it and give this another try, remember this one is asking you to open up a separate window and create a function to do this. So give it a try, and then we'll meet back here. All right, let's see how we might do this. So remember, with a function file, we start with the word function. If it has no output, we use blank brackets. And then here I need to use the title of the file. So I will need to name it something. I'll call it input output exercise 1. And then no inputs. So that's my header, and I should have a just a couple of notes here on what it does. This function creates a times table. And so I do need to ask the user which times table do they want to make. Let's say A equals input. So I'm using A again, but I'm going to use it as the result of this input. So pick a number, let's say, space, and close that. I don't want it to be a string, so I think that's good. This is the times table to print, and then I'll have x equals 1 to 10. So this is going to be similar to what we had before, a dot star x, result of multiplying. And now I'll see if I can arrange it all into a table and use that as my variable for fprintf. So let's, here's what I'm going to do. I'm going to create a filler that has spaces to put everything in, and it's going to just be ones from 1 to 10. Because what I want is an array of all A. And I want 10 of them because I have 10 factors to multiply by. So the easiest way I know of to get a matrix or an array with all values of A when I don't know what A is to start with ones and then say make that A times filler. A is a scalar, but I could put a star there if I want. It doesn't matter. So now if they put in a 7, now I have an array of all 7s. If they put in a 12, now I have an array of all 12s. So this is a tricky way to get an array. And then I can build my table, my results. The first row is going to be all this filler row. And then in the second row, I want all my x's. In the third row, I want all my y's. And then my fprintf might look something like, I'm going to pull 3 pieces of information each time I use fprintf. Each time it runs the sentence. So it's going to say the filler, the x, and the y. So I'll say .o, that'll be the first one. That's the a value. And then I use the x value. So you could use I or D here if you want integers. I'm just using .0 in the fixed point notation is, and then the third piece of information. So I don't have to tell MATLAB which one is which here. I need to tell it, let's create a new line. I need to tell it where to pull them from here at this part of the command. So they're all coming from my table. Oops, there we go. And because it's going to go down each column, let's run this real quick and I'll show you. Run. We can't run it because it's not saved. Okay, we need to run the whole thing. So I'm going to use this green triangle. It prompts me to save it and I say yes. Pick a number, I'll say 8. And there we have it. We've got the times tables where the user, in this case I'm also the user, but I picked the 8 and I put it here, and now we have an 8 times table. We could run it again and put in, I don't know, negative 1.2 just to see what happens. Of course, since I used the rounding, it's going to give me wrong answers, but that's kind of entertaining too. Obviously, this was meant for integers, so we might want to tell the user, pick an integer, positive or negative. It would probably be fine. Anyway, that's our exercise using fprintf inside of a function to control the output to the command window.